In geometry, in geometry, that's right, we're going to have a good time in some geometry today. Let's do the last section of our book, and we are going to be doing some circles, surprise, in this chapter, but we're going to be talking about more like graphing circles and equations of circles. So definitely going to be a little bit different with this last section. Now to start off here, when we would graph lines, when we would talk about straight lines, we would call this the standard form of a line, ax plus by equals c, where a, b, and c were some numbers. You might have something like 3x minus 2y equals 6, and we might take that standard form or the general form and convert it to the slope-intercept form so we could graph it, y equals mx plus b, where m and b were your slope and your y-intercept. Well, just like we can have standard forms and slope-intercept forms of lines, we can also have an equation, a standard form of a circle if we were to graph it. And it looks like this, okay? It's x minus h quantity squared plus quantity y minus k squared equals r squared, okay? And there will be three numbers involved here, the h, the k, and the r. The h and the k are going to represent the center of our circle. Okay, so whatever the h is, that's our x-coordinate, and whatever the k is, that's our y-coordinate. And the r is going to be our radius. Now, the number we're going to see is not necessarily what the radius is, but we're going to see what the radius squared is. So if we want to get r from r squared, what are we going to have to do? We're going to have to square root. Now, another thing to note here, the x and the y part pretty much stay x and y. There are instances where we may substitute in some values for x and y. Because looking at this graph, understand this. There are infinitely many points on a circle, okay? And each one of these points can be represented by a coordinate in the plane x comma y. Now, all of these x comma y's are of different value, but just understand that there are many different x's and many different y's in combination that together produces this circle. Now, if this is our equation that we just talked about, our standard form, an example might be, what if we had a circle that had a center at 2 comma negative 5 and the radius was 3? And this is how you would write the standard form of that circle. Now, one thing I want you to notice right off the bat here is the signs associated with our center and the numbers that you see written in standard form. Notice the connection between what you see for the center x coordinate and what you really write after the x in the standard form of the equation. Here we have 2, but you really write minus 2. Here, the center of the y coordinate's negative 5, but notice what we really write in the standard form of the equation is a positive 5. And that will always be true, that you will write the opposite sign for whatever your x and y coordinates are. That will always be the case. The one time that it won't be the case is if it's 0, because 0 is positive nor negative. So let's start off here with some basic problems here. What is the center and radius of each circle? Well, again, this part and this part represent the center of our circle, but it's not plus 4 comma negative 9. Again, we said we want to take the opposite of those numbers. So really it's at negative 4 comma positive 9. That is the location of the center. And the radius, again, remember this number here doesn't represent the radius, it represents r squared. So how do we get r from r squared? We need to square root what's going on here, and we get that the radius is 2. And that's it. So if we wanted to graph this, we could. We could find out where the center is located, go 4 to the left and up 9, and then stretch out 2 in all directions from the center, and there's your circle. Next up on the list. So we've got this number, so we're really going to write positive 3 for the x-coordinate of the center, but notice there's nothing written with this y. So what number are we going to put in its place? Well, we could technically write it like this, that it's y plus or even minus 0 squared. So in this case, if there's nothing there, that means you write the equivalent of nothing, which is 0. So there's the center of our circle. And the radius would be, again, keep in mind this is r squared, So we need to take the square root of that, and we're just going to leave it as the square root of 10. Now, if the square root of 10 could simplify, then we'll simplify it. If we had to graph what this thing looked like, you don't really know how far the square root of 10 is. So then we would convert it to a decimal and say that it's, approximately 3 point something. And then that way we could graph it. We would know we would need to go up, down, left, right from the center a little more than 3 in those directions. So let's go the opposite way. I'll give you the center and the radius. You give me the equation of the circle. So I know I'm always going to write, I'm going to have two sets of parentheses that are always added together here. Okay, this is key. This is always going to be a plus. If it's a minus, it's going to be a different kind of shape, which you will see probably more in pre-calc your junior year. Okay, there's always an x here, always a y here. Now all we have to do is write the opposites of these in that spot and that spot. So since that's plus 3, we write minus 3. Since that's negative 5, we write plus 5. And then equals, here's where we need to write what the r squared value is. I gave you r, so you need to square it and write 64. Don't just write r squared. Tell me what is that value specifically. And that is the equation of our circle. Now you don't necessarily need to have that, but just this part here is fine. So next up, again, x something squared plus y something squared equals, so let's go ahead and do the radius. We're going to square the 4, put 16 in its place, okay? Opposite of the 10 for the y, we put a minus 10. Now, opposite of 0, what do we do? Do we put plus 0? Do we put minus 0? You can really put that as your answer. You could put that as your answer. Or you could even do this. This is about the only time you don't have to put parentheses. As you could just say x squared plus the quantity y minus 10 squared equals 16. And that would be fine. This is probably the way that I would recommend writing it for future references. And then one more here. So I've got minus 4, so I'm going to write plus 4 squared plus y minus 1, so I'm going to put a plus 1 there, squared. And now you might think with the radius being a square root that that would be more difficult. But actually, it's easier than if it was just a whole number. Because when we square this square root, that's just going to knock out the square root and leaves us with 13 as being our r squared value. And that's our final answer. Now, two more problems. And these are going to be more the longer, drawn-out ones. This is where we're actually going to have to do some work here. So 3 says, write the standard form of the circle that has its center at the point 4, negative 2, and passes through the point 2, comma 1. So we can start to set up our answer. We know it's going to be x minus 4 squared plus the quantity y plus 2 squared equals, we just need to drop in what the r squared value is. But they didn't give us the radius. The only other thing they gave us was a point that the circle contains. Now, typically I won't graph these, but I just want to show you kind of what's happening here, okay? So if I graph the point 4, negative 2, so I go over 4, down 2, here is the center of my circle. And they tell me that the circle passes through the point 2, comma 1. So if I go over 2, up 1, this is really telling me this is where the edge of the circle goes to. So what would this distance be from here to here? Okay, so this is a point on the circle, and this is the center. So that distance in between would be the radius. I just need to calculate what its value is. And then once I figure out how big the radius is, well then I can just square it and put that number there and be done with this problem. Okay? So there are many, again, many other points that are technically on this circle. So if I really wrap around to my best ability here, that's really what the circle should look like. And it just happens to go through this 1.2, comma 1. And there are infinitely many other points that circle also goes through. Okay? But they just gave us one. Now, a couple things you could do here. Once upon a time, we used the distance formula. Okay? And it was kind of a long, drawn-out guy. And there was an alternative way of calculating that value as well. So let's see, there's 2, comma 1 again. So there's the distance formula, which was this, kind of the difference of our x's squared plus the difference of our y's squared, square root all that, and that is our distance in between. So you could use that. We talked alternatively about dropping down a line straight down and then straight over and making ourselves a little right triangle here so that we could use the Pythagorean theorem. So here, we were at 2. We need to go over 2 more. So this has length 2. Here we were at negative 2 in the y direction, and this is 1 in the y direction. So there's a difference of 3 there. So now we could just use the Pythagorean theorem to figure out what this radius is. So 3 squared plus 2 squared equals r squared. There's 9 and 4. So r squared is 13. Now you might think, let's take the square root of that so that we can get r. But if we're going to write the equation of the circle in standard form, we need to write what r squared is. So it's kind of silly to write or take the square root of both sides when later we're just going to square it. So 13 is the number we're going to want to pop in right here. And then there is the equation of our circle in standard form. Now, again, let me show you another way you could look at this problem. What I would look at, if I were doing this problem, is if I need to figure this out, I've got 2 other variables, x and y, that are preventing me from really solving and figuring out what r squared is. Now, the thing to keep in mind is this x and this y represent points on the circle. So I could plug in any x and any y that I know are on the circle into those 2 places there. Now, do I know any points on the circle? I do. I know 2, 1's on the circle. So here's what I could do. I could temporarily, this is the key thing, temporarily put 2 in for x, and I could temporarily put 1 in for y, and then figure out what does all of this come out to equal. Okay, so we've got 2 minus 4 quantity squared plus 1 plus 2 quantity squared, and look what this gives me here. This is negative 2 squared, and this is 3 squared. Well, earlier when we did the Pythagorean theorem over here, remember this was 2 and this was 3? Well, look what these numbers represent. There's really the 2. Yes, it's negative, but when we square it, it's going to be positive. And there's our 3, and we're still going to get 13. And that 13 is our r squared value there. So there is another way that we could do that same problem. So you pick which way makes the most sense to you and go for it. And our last example. Write the standard equation of a circle with diameter AB, where A is at 5, negative 2, and B is at negative 9, negative 6. Okay, so let's draw this out real quick. And you don't have to do this, just watch what's going on here. So 1, 2, 3, 4, 5, down 2. So here's point A, and B is at negative 9. 3, 4, 5, 6, 7, 8, 9. Down 6, 3, 4, 5, 6. Here's B. Okay, and if I connect those 2 points, that is my diameter. Okay, so I know my circle has got to look something around this ballpark. Okay, now there's 2 things I need to know about my circle to write the standard equation of it. Number 1, I need to know where is the center of it. And number 2, I need to know what is the radius. All right, now I could find the length, the distance from A to B, and that would give me the length of the diameter, and I could cut that value in half, and that would give me my radius. Cool. Now, how do I figure out the exact center of my circle? Well, the thing to consider is where would the center really be in my picture? Well, the center would be on the midpoint. It would be the midpoint of my diameter. Okay. Now, this is something we haven't necessarily talked about, but this is a pretty simple concept here. The midpoint is basically like the average. Okay, you guys know how to calculate an average. You add up, all the things you have and divide by however many things you had in total. Okay, but the thing about the average of points are there's 2 things to consider about a point. How many values does a point have? Well, it has two values, x and y. So it's like you need to take the average of the x's and take the average of the y's at the same time. Okay, so let's clear all this off here. So let's start with the center. Okay, so this is an x and a y, and this is an x and a y. So if I want to find the center, that is really the average of the two endpoints of the diameter. Okay, only the diameter. This can't be for any chord, specifically the diameter. Okay, so if I average my x's, here's one x, here's another x. So if I average those two numbers, 5 plus -9, there's two numbers there, so I divide it by 2. So let's see, 5 plus -9, that's -4, divided by 2, that's going to give me -2 is the x-coordinate for the center, or for the midpoint. Okay, now I do the same thing for my y-coordinates. I want to average them. What's the average of -2 and -6? And divide it by 2 because there's 2 points, or 2 y-coordinates. So -2 plus -6 is -8, divided by 2. -4 is the average in the y-coordinates. So this now represents the center of my circle. All right. So now I can go ahead and start to write the standard form of the equation of this circle. We know we're going to have x plus 2 squared plus y plus 4 squared. And again, we just need to figure out what is that r squared value. All right, so let me clear this off. And again, we got some options. We could calculate the distance between these 2 points. We could use the Pythagorean theorem again like we did before, but I'm going to challenge you to use the last method I showed you in the last example. Okay, I said this x and this y collectively represent not really a point, but really any point on the circle. Do we know any points that are on the circle? We certainly do. Not only do we know one, we know 2 points on the circle, right? Because the diameter endpoints, they would both be on the circle. So we can use either one of those 2 points temporarily as an x and a y so we can figure out the r squared value. Okay? So which set of numbers here look easier to work with? And I would think most of you would probably pick point A. Okay? The numbers are smaller, and we have one positive value at least. So I'm going to temporarily put 5 into x. So I'll have 5 plus 2 squared plus, and then I'm going to temporarily put -2 in for y. And let's figure out what this really equals, because this should be my r squared value. So this will be, oh, not 3. What am I doing? 7 squared plus 2 squared. Well, that's 49 and 4, and together that makes 53. That is my r squared value. So that's the number I want to put in right here. And that is now my answer. Now, before I leave, I want to show you a very common mistake that a lot of students will do as their answer if they do it this way. I will see a lot of students write their answer like this. Oh, 53. And they'll say, hey, that's the answer. Well, that's not really the answer. That doesn't have the x and the y back in its place. That's why I said earlier, you're only temporarily using the 5 and the -2 as an x and a y that's on there. So now you want to go back and put them back on. So you do want to see the x and the y in the very end. So that is all for the last video, and we'll see you guys later.